Hi everyone, we are the Group 2, and today we will be discussing Unit 5, Volcanic Hazards. For decades, volcanic eruptions were recorded in the Philippines. Some were recorded for its catastrophic events, while others were recorded for its mild activities. One of the largest volcanic eruptions in the recent history of the Philippines is the eruption of Mount Pinatubo in 1991. An unquantifiable amount of volcanic material has affected the Philippines socially, economically, and environmentally. These effects were felt before and even years after the main eruption. But what are the hazards from Mount Pinatubo eruption that affected many lives for many years? Were all these hazards similar from one another, or were they different? How do we recognize these hazards brought about by volcanoes? In the succeeding lesson, we will be discussing different hazards and effects brought by the eruption of volcanoes. Also, in this unit, you should be able to explain various volcano-related hazards, differentiate among different volcanic hazards, recognize signs of an impending volcanic eruption, interpret different volcanic hazard maps, and apply appropriate measure or interventions before, during, and after a volcanic eruption. Lesson 1, Lava Flow. What are lava flows and why is it hazardous to people? Lava is a molten rock or magma that has reached the surface of the earth. It is a molten material. It is not solid, liquid, nor gas, but a combination of all three. Lava flow occurs when magma contacts the surface of a volcano and erupts or overflows downhill from different volcanic openings. Lava flows can be classified as fluid or viscous, depending on its composition, temperature, and gas content. If a lava flow has a low silica content, high temperature, and low gas content, it is considered more fluid. But if a lava has high silica content, low temperature, and has a high gas content, it is more viscous. There are two types of lava flows, the pahoy-hoy and aa. As you can see in the picture, pahoy-hoy is a lava flow that has a high fluidity, creating a smooth and rocky texture when they harden. And as a pahoy-hoy cools down, it transitions into an aa. Aa, on the other hand, is a slower and more viscous characteristic of the lava, creating a blocky and jagged appearance, as you can see in the picture. Those are the two types of lava flows, the pahoy-hoy and the aa. So now, let us know the negative impacts of lava flows. First, lava flow seldom threaten human lives. It is because most lava flows are as fast as a human's normal walking pace. Second, even though lava flow can be monitored easily compared to other volcanic hazards, it is still hazardous because they can crush and bury structures and livelihood. Over time, they solidify, making the areas buried. Third, the solidification of lava also blocks road and other pathways that are commonly used by people. And fourth, lava flows also burn surrounding because of its intense heat. Wood, plants, and houses, which are flammable resources, can get caught on fire as lava flows along their path. Like other volcanic hazards, lava flow cannot be stopped. Some may be controlled. However, to minimize its effect on people's life, artificial barriers can be constructed to prevent and divert lava from flowing over a particular area. Water jets can also be used to cool and slow it down and eventually stopping its movement. Also, the use of explosives can alter the pathway and source of the lava flow. These mitigations can eventually help reduce the negative impacts of lava flow. Now, I will be giving two examples of volcanic eruptions that ejected most lava flows. One example is the eruption of Mayon Volcano, located in Bicol region. Mayon Volcano is considered as one of the most active volcanoes in the Philippines. Since the early 17th century, lava flows from Mayon volcano have been recorded. But since then, no casualties caused by the lava flow has been recorded so far. This is due to the ease of monitoring of the lava flow and the fast information disseminating to the communities about the impending lava flow arriving on the area. However, damages on properties and livelihoods were imminent, as lava flowed through the different towns surrounding the volcano. Early warning systems have been put in place by the Philippines Institute of Volcanology and Seismology, or PHIVOLCS, to minimize the casualties and lessen the effects of these lava flows to the community. Another example is the eruption of Kilauea volcano in Hawaii. Mount Kilauea is one of the most recognizable volcanoes in the world that produces lava flow. Hawaii is made out of active volcanoes. This is why people in Hawaii have seen volcanic hazards as part of their daily lives. This is the map of Hawaii. It shows the different volcanoes found in the island. As you can see, most part of Hawaii is highlighted with mid to high risk of hazards occurring. These zones are areas where lava flows are previously occurred and are expected to occur once new lava erupts. And only less than half of the island shows low-risk hazards happening because little to no volcanic activity occurs within these zones. In this lesson, you've known what is lava flow. You've also known that there are two types of lava flows, the pahoehoe and aa. Also, you learned the negative impacts of lava flows and the mitigation on these effects. And lastly, you've learned that the eruption of Mount Mayon and Mount Kilauea are examples of volcanic eruptions that produces lava flows. The next lesson will be discussed by Ms. Robles. Take it away, Marian.
Thank you, Carol.
Lesson 2. Volcanic Gases. What are volcanic gases and why is it hazardous to people? Volcanic gases.
One of the most common volcanic activities that happens during, before, or after eruptions. And it has materials depending on its locations. Examples are water vapor, carbon dioxide, sulfur dioxide, hydrogen chloride, and hydrogen fluoride. Volcano hazards are not mutually exclusive. Different volcano hazards can occur at the same time, just like how volcanic gases occur with or without lava flow. Negative impacts of volcanic gas. Number 1. Acid rain can lessen water intake by plants, making them difficult to thrive. It leaches off plants' nutrients out of the soil, which causes it to be less productive for agriculture. Number 2. An increase in the acidity of aquatic bodies is harmful to plenty of animals and can damage buildings, cars, statues, and other man-made structures. It leads to lower body mass and weight and makes the fishes hard to compete for their habitat and food. And worst case scenario, it is seen that aquatic acidity seems to be an interference for their reproductive cycle. Number 3. Direct contact with sulfur dioxide can irritate our eyes, rash our skin, and cause or poison our respiratory system. Number 4. Carbon dioxide can also cause asphyxiation without warning because of its odorless and colorless nature. Mitigating the negative effects of volcanic gas. Number 1. Monitoring volcanic gases with the use of the different techniques given by the Volcano Observatory to see whether if a volcano is emitting hazardous levels of volcanic gas. Number 2. Wearing of masks is recommended. Number 3. Leave the vicinity immediately once the volcanic gases have been released in the atmosphere. And lastly, public awareness of the different types of volcanic gas hazards. Example of these are, number 1, the disaster in Lake Nyos. It was one of the most notable disasters that occurred because of volcanic gases, which happened on August 21, 1986 in Lake Nyos, Central Africa. It was a rare natural disaster which occurred in the West African country of Cameroon. A large cloud of carbon dioxide spewed from Lake Nyos blanketed and killed 1,746 people along with 3,500 livestock while they slept. Number 2. The sulfur gas of Mount Ijen. An active volcano named Mount Ijen, located in Java, Indonesia, releases high amounts of sulfur-rich gases, volcanic gases, in which is responsible for the natural phenomenon dubbed the blue fire. According to experts, the blue fire results from the crater's sulfuric gas igniting as it emerges and comes into contact with air without producing smoke.
So what are pyroclastic flows and why is it hazardous to people? Pyroclastic flows are hot, dry, turbulent mass mixtures of various pyroclastic materials that move downward along the slope of a volcano at a speed that then go up to several hundred meters per second. Pyroclastic material, or also known as tephra, are volcanic fragments that have been ejected from a volcano that ranges in sizes from ash to boulders. Pyroclastic flows are composed of two parts: a basal flow of coarse pyroclastic materials, and a turbulent ash cloud riding over the basal flow. Pyroclastic surge happens when the turbulent ash cloud splits from the main pyroclastic flow. Pyroclastic surges have lower density and are more mobile than pyroclastic flow due to their higher ratio of gas to tephra. Types of pyroclastic flows. Pyroclastic flows occurs in various ways, but the most notable type is called the sulfuric type. This forms from the collapse of a high vertical column coming from a highly explosive eruption. When gravity overcomes the upward drive of an eruption's momentum, the pyroclastic materials begin to fall, forming a pyroclastic flow along the volcano's slopes. On the other hand, the pili type occurs when a highly viscous lava dome blocks a volcano's opening. Pressure builds up until it can no longer be held, and the volcano explodes to one side without forming a high eruption column. Lastly, the Merapi type occurs when a lava dome grows too steep over a volcanic crater, which then falls due to gravitational force.
Negative impacts of psychoclastic flows. Number 1. Psychoclastic flows cannot be outrun and are a major cause of death in volcanic eruption. Number 2. Psychoclastic flows can set buildings on fire, badly damage buildings, and even destroy them. Number 3. There is no protection for those in areas affected by psychoclastic flows. Number 4. Psychoclastic flows are so fast and so hot that they can knock down, shatter, burn anything in their path. Number 5. Psychoclastic flows can be extremely destructive and deadly because of their high temperature and mobility. Mitigating the negative effects of psychoclastic flows. Number 1. If the psychoclastic flow is headed toward you, leave the area immediately. Number 2. If you can drive rather than you walk, use your vehicle to evacuate. When driving, keep doors and windows closed. Drive across the path of danger if you can or away from the danger. If you cannot, and watch for unusual hazards in the road. If you are indoors, number 1, close all windows, doors, and fireplace or wood stove dampers. Number 2, turn off all fans and heating and air conditioning systems. Number 3, bring pets and livestock into closed shelters. If you are outdoors, number 1, if near a stream or river, be aware of rising water and possible mud flows in low-lying areas. Move up slope as quickly as possible. Number 3, seek care for burns right away. Immediate care can be life-saving. Examples. Number 1, Mount Pinatubo eruption. one of the 5 greatest eruptions of the 20th century, erupted on June 9, 1991, and continued to erupt weeks after, created a disastrous cycloclastic flow that traveled as far as 16 kilometers from the volcanic vent. 20,000 indigenous people and more than a million lowlanders were directly affected. 200 to 300 people died.
What are ballistic projectiles and tephra falls? And how do these phenomena affect people's lives? But first, let's talk about tephra. Tephra are fragments of volcanic material that are ejected into the atmosphere from the eruption of a volcano. They are differentiated based on the size of the ejected fragment, which are ash, which is less than 2 millimeters in size, lapilli, which is 2 millimeters to 62 millimeters in size, and blocks and bombs, which are greater than 64 millimeters in size. These blocks and bombs get spewed out and eventually become ballistic projectiles, which are large tephras that leave the volcanic vent with force and trajectory. And tephra falls occur when tephra is being spewed out by a volcanic initially hovering and riding over the prevailing wind direction before eventually falling into the Earth's surface. With all this destruction from the eruption, it has negative impacts to its environment and its surrounding, which are the destruction of property and endangerment of lives because of the force of impacts of these ashes. It can collapse roofs, destroy electrical lines, and destroy agriculture. Tephra falls can also carry harmful and poisonous particles and gases, and it also may block drainage, sewage, pumping stations, and critical facilities. With all of these negative impacts, which can also be mitigated, because some tephra falls hazards can be practically mitigated to minimize its destructive effects without the need of evacuation. First is to be able to clear out the ash fall buildup before it accumulates. Second is strengthening the structures will be able to withstand the load of ash buildup. And thirdly is to wear masks and respiratory apparatuses that can significantly reduce the inhalation of ash and poisonous gases. Example of this phenomena is the volcanic ashes of Eyjafjallajökull, which is located in Iceland and erupted in 2010. It had such a massive amount of ash that it released, which resulted to disruption of traffic in large parts of Europe. And then the eruption of Mount Vesuvius, which erupted in 1944 during World War II in Naples, Italy, which hampered the war efforts of the Allied forces against the Germans during World War II.
Lesson 5. Lahar. Lahar is an Indonesian term for mudflow that has been globally used as a term for a specific type of mudflow. Lahar is created when a tephra mixes with water and forms a slurry. It incorporates other materials along its path, which can result in its volume growing more than 10 times its initial size. Lastly, lahars can occur with or without any volcanic activity. Two types of lahar. Number 1. Primary lahar. It is formed when pyroclastic flows occur along areas where bodies of water such as streams and rivers are present. Number 2. Secondary lahar. Formed after an eruption event and is generated when rain falls on unconsolidated tephra and mobilizes them downslope, collecting more tephra as it progresses downward. The negative impacts of lahar. Number 1. Lahar can destroy cities and kill countless lives. Number 2. Lahar is hyper-concentrated near its source. And diluted lahar can fill and bury an urbanized or agricultural area. Lastly, a freshly deposited lahar can also act like quicksand that hampers immediate search and rescue efforts.
Mitigating the negative impacts of lahar. Lahar flows cannot be predicted easily because they can occur with or without volcanic activities. Their exact source of magnitude are also challenging to pinpoint before its onset. Risk reduction measures can be designed to lessen the risk of lahar. The negative impacts of lahar are education for the community and local government, and designate the specific risk reduction measures. Basic risk reduction strategies. Number 1 is hazard avoidance, a complete ban of development in lahar-prone areas, and it is also the elimination of hazard activities and exposures that can negatively affect an organization assets. Number 2, hazard modifications. Engineering structures to protect the affected area by diverting or blocking lahars, or weakening or preventing lahar flows altogether. 3. Hazard warning. Disseminating information to the community of an impending lahar flow before it reaches and affect the community. Hazard response and recovery planning. Strategy plans on rescue of those affected by the hazards, how they will be taken care of, and the identification of long-term plans for the affected community. Lahar depositing years after the Mount Pinatubo eruption of 1991. Lahar formed within hours following the explosion of Mount Pinatubo. Heavy rainfall mixed with the fresh tephra ejected by the volcano. Lahar flows reach speed of more than 80 kilometers. Lahar continued to form even years after the initial occurrence. The lahar has taken many lives, destroyed buildings and infrastructure. Hazard warnings have been put in place to evacuate the locals before the hazard occurrence. The repairs of infrastructures, the various effects of lahar on the communities around Mount Pinatubo have led to more robust program aimed at mitigating the risk of future hazards. Primary lahar from Mount St. Helens in 1980. The violent eruption of Mount St. Helens in 1980 was considered as the worst volcanic disaster in the United States. One of the hazards of the eruption resulted an advancing pyroclastic flow. This produced massive lahar that grew bigger at engulfed more materials, more than 200 homes and 300 kilometers.
So that's the end of our discussion. We hope that you learned a lot from this unit. Thanks for watching.